Alrighty, I think we're live. Okay, I'm going to get us started. If someone from the audience can hear me, okay, beautiful. Do leave me a message. But all right, amazing. Um, Thanks very much for joining. We're in the closing keynote session of Like Mother Earth. And it's pleasure to have Dr. Pant with me. I'm going to do a quick intro for you. So basically, I'm Asan. I'm one of the organizers of Like Mother Earth, and head of data science at RBC. So let me do a quick intro for my great friend Vic Pant. So Dr. Pant is a partner and in the data analytics and practice, where he focuses on client value realization through creative and innovative application of data science and AI in PwC. He is also the former chief scientist and chief science advisor at Natural Resources Canada. He's had many titles over the year. I'm going to go through a few of them. So prior to joining PwC, Dr. Pant served as the Chief Scientist and Chief Science Advisor at Natural Resources Canada, as mentioned, a federal ministry within the Government of Canada. Previous to NRCan, Vic held progressive strategic field and corporate roles in global software firms, including SAP, Oracle, and OpenText. Vic is also an adjunct professor in the Faculty of Information, iSchool, at the University of Toronto and the Department of Geography, Environment, and Geomatics at the University of Ottawa. He is also the founder of the Synthetic Intelligent Forum, which is the leading community of practice on applied AI and data science for researchers and industry professionals. Dr. Pant earned a doctorate from the Faculty of Information iSchool in the University of Toronto, where his thesis was unanimously accepted by the examination committee as is and without any changes. That's very hard. So much congrats on that. A master's degree in business administration with distinction from the University of London, a master's degree in information technology from Harvard University, where he received the Dean's List Academic Achievement Award, and an undergraduate degree in business administration from Villanova University. NRCan is the federal government, for those who are not familiar with the institute, federal government ministry responsible for developing policies and programs to enhance the contribution of the natural resources sector, the economy, improve the quality of life for all Canadians, and conduct innovative science in facilities across Canada to generate ideas and transfer technologies. Dr. Pant led the Office of Chief Scientist at NRCan and reported directly to the Deputy Minister. His office oversees the development and implementation of evidence-based science policy across NRCan sectors and agencies. His office also manages NRCan's enterprise-wide technology strategy and portfolio of science products. He also ran the Digital Accelerator, which is an innovation platform for designing and launching AI-driven software products in NRCan. He also represented NRCan on executive-level science and technology committees and delegations in Government of Canada. NRCan focuses on renewable and traditional sources of energy, forests and forestry, minerals and mining, clean technologies and energy efficiency, with the objective of benefiting Canadians by creating a sustainable resource advantage. Finally, NRCan's science expenditures total approximately $500 million per year, and NRCan employs 2,800 scientists and researchers across the country. NRCan scientists partner with academic and industry researchers to conduct fundamental and applied science via a network of 19 major laboratories, science centers, technology facilities, research science, and permanent sample plots. So with that, it's great honor and pleasure to welcome Dr. Vic Pant. The floor is yours.
Thank you very much, Ehsan. It's my pleasure to be here. And First of all, I'd like to start by thanking the organizers, the conveners of this most important conference for inviting me and giving me the privilege to present here. I understand how difficult it is to organize conferences and to get speakers and to arrange the right kind of topics and to then get the right mix of folks involved. So really, kudos to you. I've looked at the lineup. I've enjoyed some of the sessions. Just really great work to the organizing committee for this, and hope to be a part of this community going forward as well. I'd also like to, as you very kindly mentioned, Ehsan, like to say that I started my career in the private sector, which is where I spent the majority of my professional career, and then I had the great fortune of actually getting recruited by the government of Canada, where I had the privilege to serve Canadians for about 3 years, 2.5 years, and then when that contract was over, then I returned to the private sector, which is really where my roots are and which is where I feel I needed to return to at that point in time. So today I want to talk. This conference is about geospatial intelligence and location intelligence. So I want to talk about a case study in a sense, or if we can call it talk about a system or a software service that I think folks would be quite interested to use if you haven't already started using it. But I want to also take a look at it from another lens, which is the lens of collaboration, which is the importance of just people coming together, organizations breaking down barriers and silos to cooperating, and truly in the spirit of partnership and allyship, build something that benefits Canadians from coast to coast to coast. So really, I call this the power of collaboration, and really what we're going to showcase this is the idea of what's called, or the service that's known as the Open Science Data Platform. But before we go into that, let me set a bit of the background. Let me set a bit of the context. So in 2018 and 2019, in that time frame, there was a bill called Bill C-69, which eventually got approved. And the whole idea behind the bill was, as you look from the name of this bill, an act to enact the Impact Assessment Act and the Canadian Energy Regulator Act, and to amend the Navigation Protection Act and to make consequential amendments to other acts. So this was a quite a far-reaching and quite a encompassing piece of legislation that received royal assent. So sort of between the 2018-2019, and it became the law of the land. And when you look at the text of this law, you'll understand how comprehensive and how inclusive and how broad this piece of legislation is or was, and now it's the law of the land. But it really called out this very important facet, and this facet is called cumulative effects. And when you read the language of the bill, you find this phrase, cumulative effects, mentioned in a couple different places. For instance, in one of the three clauses, where I've just simply for illustrative purposes put it out here for your reading, you see it talks about the idea of cumulative effects of existing or future activities. And then it talks about the notion of impact assessment. In the next one, it talks about cumulative effects and impact assessments. And then it talks again about cumulative effects, right? So when you think about it, it sort of begs the question of, okay, well, what is cumulative effects, right? This is a big piece of legislation. It's a comprehensive and a rather wide sweeping law of the land. So what is it that is cumulative effects that is such an important part of this, or central facet, some would say, of this piece of legislation? So what is cumulative effects? When you think about it, really there's two main generally accepted definitions. There's certainly many others as well, and academics have studied this topic and practitioners have focused on this topic for quite some time. But one way to look at this is to think about changes that accrue and accumulate through time and space. So that's sort of like a broad way of thinking about cumulative effects. Another way to think about it is the idea of combined effects. So really, there's two things going on. One is we're looking at things, if you pick a point in space somewhere, we're looking over time as opposed to just at a point in time of the changes which are accruing and accumulating from a temporal perspective, over a long horizon. But also, it's the interplay, it's the interaction of different drivers, different factors, different phenomena that are coming together to then drive those changes, which are resulting in those impacts, right? And when we think about us, as humans and sort of our environment where we live and we work and we sort of operate and exist, so there's two main sets of contributing factors that drive these cumulative effects, right? So one is natural effects. If you think about the environment, there are things, natural phenomena, wind patterns, rainfall patterns, different types of geological activities, things of that nature. So there's certainly natural factors, but also there's human activities, right? We know that, and especially nowadays in the debate around anthropogenic climate change, we quite often hear that certainly there are human beings that are responsible for doing things that are causing an impact in one way or another. And then certainly there are natural factors as well, radiative forcing, things around the Earth's albedo and various other factors. So when you think about what are the drivers to what causes cumulative effects, you can think about it as human factors, human caused factors, and we can think about them as natural factors as well. So when this bill became the law of the land, the bill received the royal assent, and it became something that the government had to enact and government had to implement. So here I'm showing you in the 2018-2019 timeframe the implementation types of notes and decisions that started coming out of various federal departments. Right? When you think about it, we have in our Canadian system, we have our elected officials. They are the legislators. They are in the House of Commons, and then we also have the Senate. And then they are the ones who are proposing policy, they're proposing bills, and then there's a whole process through which bills go, and then they become laws, some of them. And once they become law, then we have the Federal Civil Service, which is then tasked with implementing the federal laws, right? So when you think about it, when C-69 was enacted as the law of the land or adopted as the law of the land, one of the things that came out of this was you'll see in the bottom, I've underlined some text from a document which says that NRCan, the department where I was working, in partnership with Environment and Climate Change Canada, will deliver what's called the Open Science Data Platform, right? So now, how does this story kind of fit together? Is we had Bill C-69 that talked about the need for having impact assessments of cumulative effects resulting from resource development projects. So if you are a resource developer and you want to get a permit or you want to get the approval to be able to go and build this thing out in the real world in somewhere in Canada or in Canadian jurisdiction, then you would have to submit for consideration to the review panel a proposal, and that proposal will include an impact assessment that will say that, okay, well, if this project is to go through, then these are all the things that we can expect to happen. And certainly nobody can predict the future and nobody can know it 100%, but the idea was that there would need to be this way for people to or reviewers or proponents of resource development projects to be able to put forward a position that says, okay, if this project goes forward, these are going to be the effects in various different ways, right? So think about it like that. Now, another big part of the Bill C-69, or an important part of Bill C-69 when you read it, is that it talks about this notion of public consultation, right? Because it's very important in our system of democracy where we want there to be social license, we want there to be civil, approval of different decisions that are being made by the government and rules which are being enforced by the government. So there is a section in there that talks about the need for public consultation, for getting people involved, right? Because it's one thing to say that you have a resource developer that's proposing some kind of a project and they're writing some document which is going to the review panel. Well, it has to be done transparently because it has to be done where people can take part in public hearings, people can have their comments heard, people can have their perspectives looked at and considered in the decision-making process. So this is really an important part to the reason behind why the Open Science Data Platform became what it became, right? And that's the tool that we're going to be talking about today from a geospatial intelligence perspective. Now, when we talk about cumulative effects, right, this is not a comprehensive or an exhaustive list, but you can think about what are some types of data sets, what are some types of topics or subjects that one might be willing to look at when you're thinking about this notion of impact assessments or cumulative effects, right? Think about some major resource development project that's being proposed in some part of Canada or somewhere in Canadian jurisdiction. So what are the various lenses through which that project can be assessed vis-a-vis the impacts that it's going to have on our environment, on us as people, on the flora and fauna, on the ecology, right, on the biodiversity of the country. So lots of different things you can look at. So, there's air to consider, water to consider, climate effects to consider, biodiversity, land, economy and industry, health, society, and culture, right? And to go back to the original point I made is that it's not just about at one point in time, what effect will it have on a water body in some place or the air quality in some place. It's actually over time, how will it evolve, how will it change, what will be the dynamics involved in the system. But also when multiple things come together, when there's a resource development project proposed here and there's another resource development project proposed somewhere else, then how is it going to actually come together, and how is it going to combine in time and through time? Okay, so that's some of the relevant factors. Now, from an analysis perspective, you could be an informed citizen, you could be a proponent, you could be a regulator, you could be somebody who serves on the review panel. So irrespective of what your role is, you want to be able to look at any and all of those facets which we just talked about from a geospatial perspective, right? So the way to think about it is, we have a map of Canada, and I want to look at sort of air, right? I want to look at the air dimension. So one of the things which I'm very interested to look at, if that's the lens I want to take for this part of the analysis, would be, for instance, the concentration of particulate aerosols in the atmosphere, right? Different kinds of particulate aerosols and different kinds of suspensions and things like that, right? There may also be other things we want to look at, which is what's the air quality like as measured in some other ways. Are there changes in the patterns of how fog occurs, or smog occurs, or things like that, right? So air is one thing that we certainly want to look at when we are trying to understand what the effect of different activities or different projects is going to be on the environment and in our context. Another way to look at it is when we think about it from with respect to water. In Canada, we're very fortunate to have very large reservoirs of fresh water. Also, Canada has, coast to coast to coast, as we say. So the idea is that just like air is an important dimension to consider, we also want to look at water. And we know that water quality and water characteristics are measured by academics, they're measured by researchers, they're measured by government scientists, they're measured in some cases by private sector participants. So how do we visualize that? How can we then put that on a map and start to understand that, oh, if we're going to be building some resource development project here, or we want to analyze this polygon of lat longs for some kind of research that we want to do, then what is the quality of water going to be there, right? So that's something also that is relevant for doing cumulative effect assessments, impact assessments as well. Climate, which is certainly a very, very important topic. So what can we do with this lens? Can we look at greenhouse gas emissions? Can we look at things like, the permafrost? Can we look at things like our ice cover? Can we look at changes in those types of factors through time and over time and compare them to different locations and things like that? So, looking at climate change and changes there is also very, very important. Then biodiversity. So we have, for instance, caribou, we have salmon, and in some cases, they have cultural significance, they have traditional significance. In many cases, they have economic significance. And also, when we think about biodiversity, we think about things which are caribou and salmon and the types of things which we naturally consider to be a part of the environment. But also, we consider things like pestilences and infestations, right? They can have effects on industry, they can have effects on health and well-being of people. So we also want to be able to visualize and render on our map to be able to do cumulative effects assessments and impact assessments, this kind of biodiversity layer or biodiversity information as well. Another thing to look at is just land cover, right? So we talked about, for instance, the different kind of composition of our terra firma. So if, for instance, up at a certain point in time, if in the month of January or February, the ice cover was up to a certain point, and then now we're seeing that the ice cover is actually receding and things like that. So we want to be able to monitor that, right? It's our forests are in a state where are they receding, are they growing, what's the health of the forest? So we want to be able to model that as well. Just to be able to look at this from an impact assessment perspective as well. So for instance, if human activities or resource development projects are going to in some way impact what the land cover is going to be, or at least in a certain point of space, then that is something that is germane to our analysis. Economy and industry. I mean, certainly when we think about human activities and resource development projects, the rationale behind them in many cases is economic, it is industrial. So that is something we want to be able to juxtapose in our analysis and bring together, and to be able to analyze, okay, well, this is really where this other kind of economic activity goes on already, where this new kind of economic activity or project is being proposed. So what does that mean, and how does that work, and things like that. So that's another dimension, another lens that we can take a look at. Health. So ultimately for us, as humans, we want to see that, okay, well, if air quality is going to change in one way and water quality is going to change in another way, and perhaps there is some kind of other radiological elements will be introduced in certain environments, then what is that going to do to our health, right? As people, so we want to be able to account for that. We want to be able to accommodate that in our analysis as well. And then we have also society and culture. So in Canada, we really, look at, when we do this kind of analysis, we want to look at it with respect to, are we doing things which are responsible and respectful to our First Nations communities? What about, we have certain parts of Canada where one language is spoken more than the other official language, and other parts where it's the other way around. So we want to really be able to take a look at Canada's heritage, Canada's traditions, Canada's culture, and Canada's sort of social makeup, and be able to incorporate that into the analysis as well, right? So backing up a little bit, as I said, C69 came out, and really an important part of that was this notion of cumulative effects and how one needs to account for the impacts of those cumulative effects through time and over time, and through the intersection of various different drivers and causes and factors, from multiple different lenses, some of which I've just talked about very briefly here, right? So given that that is the need and that is sort of what is required, and from the perspective of an informed citizenry and people in Canada that have a say and that should be able to self-serve and do this kind of analysis in case they're interested to participate in the process of examining and reviewing and having their comments heard when it comes to what gets sanctioned and what gets permitted or not, then that's really where the Open Science Data Platform came from, right? So it's a web-based service. Anybody can go to it. It's publicly available. It's changing all the time. Really an exemplary platform. And I know my former colleague, Eric Loubier from the Canadian Centre for Mapping and Earth Observation is in this conference as well presenting. So I highly encourage you to, watch his talk or watch his recording. Mr. Anil Arora, the really exemplary leader of StatsCan. He's really, his department has contributed some fantastic data sets and really set the tone in terms of how good open science, open data is done in government, and really led to the creation of this platform. So lots of really interesting partners have come together to bring this solution into reality. But anybody can use it. Go ahead and take a look and start using it. I just want to tell you a couple of quick things around how this tool works and how you can use it in a beneficial way. So this tool, you can actually, because the rendering, the visualization is in a geospatial frame, so you can navigate the map and you can add layers the way that you want to be able to inspect and interrogate different types of data sets on that map, projecting them on the map to do your analysis. But another way to do it is you can do keyword-based searching, right? So for instance, here in this example, I am searching for the word lithium, right? So just because maybe I'm an informed citizen and I'm curious to know, okay, where are some lithium mining or lithium refining or processing types of activities or plants that are being built or have been started already or have been completed and decommissioned in Canada. So I can search for that. And once I search for that term, I get some results back, right? Now, the interesting thing about these results is there's a plethora of results. So even for this keyword, I have 187 results that came back, of which 178 are high quality curated publications, which are now included in the results. I've got some data sets, and I've also got some other development activities and some details about them that are relevant for this kind of analysis, right? Now, you could be a regulator, you could be an everyday Canadian, you could be somebody from the proponent side, you could be somebody from some other interest group that is, let's say, opposed to some kind of a resource development project. So anybody can use this service. And when you come in, you get this kind of a visualization that shows you high quality, highly curated results in your search. Now, one thing we can do is we can actually go and click on this link called mappable content. Okay, so not everything is mappable. You get the results, but when you click on mappable content, what it does is it actually projects the relevant data into a map. Okay, so I'm just going to click on that. So so when you click on more mappable content, the list shows up, and I'm going to pick one at random for the demo. I picked one, James Bay Lithium Mine Project, for no particular reason than to show you how it works. But you click on that and you see it has this link because it's a mappable piece of content. It says map area. When you click on that, it actually shows you this result. It pulls up all the details associated with the James Bay project on a map. So I'm showing you what the full screen looks like. So the search results are below the actual map on top. Okay, but if you zoom in on the map, what you see is this is what it looks like. Now, this tool is actually this solution, Open Science Data Platform, is running on what's called the Federal Geospatial Platform, which is a tool that was led by the Canadian Centre for Mapping and Earth Observation and built in collaboration with multiple federal agencies and other partners. So really a true collaborative team effort. So not only is the Open Science Data Platform a success story of collaboration, but in fact the system on which the OSDP content is served and run, then that is also a true story of collaboration in the government of Canada, right? So I'm just going to try this. So if I click this full screen button, I think it shows this slightly differently here. Oh yes, I think that was a comment for the audience if you wanted to see the attendees, the map in bigger detail. So just to show you that. So now the nice thing here is you can also see a legend on the side which is saying, okay, the green ones are the ones which are completed projects associated with lithium in some way. Some are in progress, some are terminated, and so on and so forth. So it's a nice map where that content is presented. Now, one of the things you can do is you can scroll down to the below the map to where that list of search results is. And here, if you click, for instance, on the link called view, so when you click on that, it actually takes you to a data set or to some content that describes what this particular point in the data set corresponds to. So here in this case, because this is a resource development project, we are taken to a page that is showing us the details about this particular project. And the other thing we can do is back on those search results, when we click on the information button, we can see the metadata associated with this particular record. Okay, so here what we are seeing is that this particular data set was, or this point in the data set was provided by the Impact Assessment Agency of Canada when it was submitted, when it was last updated in their system, and the system updates over time, with the source systems that it pulls from. So you can see when most recently it was updated, within the last week, within this week. And at the very bottom, you'll see that one resource that is associated with this point in the data set or this record in the data set is the link to the website, which is what when we clicked on the info, it took us there. But if you had PDFs, if you had video clips of some surveys, if you had audio recordings or transcripts of some public hearings about the approval or the consideration for the approval of this project, all of that is publicly available right from this one single source. And if there's any peer-reviewed articles or conference proceedings or something where there are articles that map to something that is relevant to this field, then you'll see it all nicely integrated right there. So it's a geospatial visualization platform at one level, but in fact, because all of the data has a lot of very meaningful, rich metadata behind it, then you also get to benefit from the information trail that you can follow in the interest of traceability and discovering other interesting things. Okay, so yeah, when you click on that, it takes you right there as I showed you before. Okay, so now another thing that I want to show you is that if we were to go in and now remember, I'm just zoomed in just so I can show you what the map is on the top, and then down below is the search result. The map is still on the top. But let's say that I looked at the lithium developments in the region of the James Bay Lithium Mine project, right? But let's say that now I want to take my analysis to the next level. Is I want to say, okay, well, I want to now look at where are the First Nations communities, where are the Indigenous Canadian communities in that lat long box that we have zoomed in on in our map. So if I simply go and I run a search for First Nations locations, same search results area, I get to see different search results now. So here you'll now actually see we have the third link down there is called First Nation locations. And then you see something called add to map, right? So just like I showed you before, how you can add a resource development project or any other information that you have sought and found and hit add to map. Now you can actually do the same thing and add another layer to the map. And then sure enough, here we go. So now we see that near James Bay, there isn't exactly a First Nations community very, very close, but you do see that for one of the other development projects, which is to the bottom and to the right side of the screen, you do see that there is a Nemeska Cree Nation community there, right? So maybe now you want to look into that a bit more in a bit more detail. So what we can do is we zoom in a little bit there and we say, okay, well, what is that resource development? Actually, this has two resource development projects not too far from it, at least in this map, the way we're looking at it now. And so what we can do is we can click on one of those resource development projects to the right of it, which you see that I've now clicked on, and it shows you the metadata stub or the metadata details associated with that. So that was a Whabouchi mining project, when it started, when it ended, what's its current state. And then certainly, like I said before, when you double click on it, then you can actually start to search and look at the various other documents and assets and resources related to it that you can zoom in on detail and dive in as well. Uh, and of course, I just showed you 2 layers in the interest of simplicity, but the thing that you can certainly do is you can add all kinds of other layers if you want. If you want to add a layer around water quality monitoring or air quality monitoring, then you can add those types of layers here as well. And then as long as it's visually understandable and interpretable by you, then certainly you can go ahead and add layers and do a very comprehensive and an inclusive analysis in that way. Now, as I mentioned to you before, the Open Science Data Platform content is housed and rendered on the Federal Geospatial Platform, a really phenomenal tool which is used for all kinds of Government of Canada data rendering, geospatial data rendering projects. But OSDP is one of the implementations or one of the applications running on FGP. But some of the things you can do with FGP is you can actually go ahead and change the base maps. So sometimes you want to be looking at things in monochromatic versus you want to look at it in color. Sometimes you want to see different kinds of geographical contours or different geographical reliefs. Sometimes you want to look at sort of the transportation network. Sometimes you want to look at some other, depending on the kind of analysis you're doing, you can switch out the base map, the base layer of the map in the solution, very straightforward way, in a very straightforward way, so as to help enrich your analysis. Another thing you can do is you can actually make whatever part of the map you're zoomed in on, you can actually export it. So when you click the export button, it will basically give you the ability to choose what you want to show and what you want to be able to transfer to others. So this will be a point in time rendering that you can send to people on an email as a PNG or any other kind of file format that you're interested in. So this is something that you can use as well. Another thing you can do is, in some cases, you don't just want to take a point-in-time snapshot. You want to give somebody access to your active view. So what you can do in that case is you can just click and get to the share button, and the share button will give you a link that you can then click on and then share it to whoever you want. So when they actually navigate to that link, they will get that pre-zoomed in view with exactly the right layers and exactly the right type of points of interest visualized on that map the way that you had wanted to share it with them. So more of like a living kind of a document, because obviously over time, there may be new data sets which are onboarded in the FGP into the OSDP on top of FGP, or there may be some changes which have now emerged from the time that you shared the link. So sometimes sharing static documents is helpful, but other times having a dynamic kind of a view directly accessible to people is also very helpful. So this is kind of what the tool looks like, and it's a really powerful tool that you should maybe consider using in your own analysis. Another thing we can do is you can also bring your custom data and just project it onto this data set. So when you go into the map and you click on the layer button, here you can see there is some transformation you may need to do. You can specify lat long coordinates, or you can specify basically polygons, right? It depends on what it is that your data set is composed of and how it's structured, but you can essentially, there's some documentation that tells you how your data set needs to be structured, but actually even the formatting and some of the transformation can be done in the just prior to loading the data set in this tool. So you can do that and really bring some of your domain specific or organization specific knowledge into the platform for your own visualization as well, right? So this is really what the Open Science Data Platform is, and like I said, publicly available. It's public dollars really creating knowledge and creating awareness and citizen engagement and just getting Canadians informed about things that matter, things that are important for them to know. So that's what this platform is. Now, like I said, this kind of a platform requires lots and lots of folks to come together, to collaborate, to work together, and that's exactly what this is. And you'll see a select list of contributors there, and you'll notice most of the major science-based departments in the federal government, many of the economic departments in the government of Canada, all contributed data sets. They all provided subject matter expertise. Because when you think about it, right, it's not just a question of submitting a data set and uploading it into a platform. There's a lot of prep work that goes in. There's a lot of going from the what to the so what that happens to, right? If you're measuring, let's say, water quality at some points in Canada, or you're measuring air quality at some points in Canada, it's one thing to have those measures. It's another thing to be able to label those measures, right? Maybe in one part, some measures are unacceptable for various contextual reasons, and they are maybe not acceptable in other reasons, other regions, right? So there's a lot of that kind of science interpretation that goes on when we take a data set in its raw form and then put it into a tool like this, because certainly just putting raw numbers up there or raw measurements may not be as helpful to certain audiences or users of this tool as they may be to others, right? So lots of expertise provided, lots of data provided, lots of thought leadership provided, and just really a lot of this partnership provided by lots and lots of federal departments and agencies, as well as you see, provincial and municipal players as well, in making this tool the success that it is today. Now, what are some possible future directions? I'm no longer at Natural Resources Canada, but at the time that I was there, a lot of great discussions were taking place in the department, also in other departments that were on the steering committee of this tool. But with a tool like this, the first thing is adding more data sets, right? Because the tool gets more and more useful. And one of the things we found when we were doing user feedback, when the tool was rolled out last year, sort of came out of beta and was actually was released in the public general availability, one of the things we heard from a lot of folks was that data really has this multiplicative effect rather than an additive effect from a complementarity or a synergy perspective, which is when you have a tool like this with 5 data sets and you add a 6th data set to it, okay, it's useful, but now you have 6 data sets. But when you have 50 data sets and you add 2, 3, 4, 5, 6 new data sets onto it, they really have that kind of complementarity and synergy, because now you can really slice and dice different phenomena, different factors, different drivers in ways that were not previously possible, right? So adding new data sets, updating existing data sets, and you can imagine that's a non-trivial exercise, because sometimes when you have in the source systems data sets which are getting refreshed, then sometimes there may be some corrections made that the data set itself might not reveal what that correction was or what that transformation was, to maybe adjust for some prior anomalies and things like that. So when you bring that in, you have to also bring that in with metadata. So it's not just a question of having a service that's polling some shared object store and then updating the database behind the scenes just arbitrarily. You have to understand the schema. You have to understand what the pre-processing pipelines were in the source systems, so that when you're making changes here, that the changes aren't completely incompatible from a conceptual perspective. Automating the data preparation. Oftentimes, just like in any other industry, in any other context, data may be messy, it may be unclean, it may be incomplete, it may be maybe in some way not appropriate for usage in the ways that it's supposed to be. So a lot of human effort goes in that data preparation, that data readying aspect of the pipeline. So having advanced artificial intelligence tool and data science tools to be able to analyze data as they are coming into the ingress nodes of this stack, then it's good to make sure that maybe not everything is automated, but it's quasi-automated, where some of the easier tasks or some of the more computationally tractable tasks are handled upstream automatically, and then human experts can free up their time to do some of the more heavy lifting on that as well. Introducing a temporal dimension. This is one of the things that I was most, and I'm still most excited about in the solution, which is, one thing which you didn't see in this tool when you see it yourself right now is a slider, right? It's the time machine view. And so that's something that quite a few users in our early testing had at the time discussed, like, hey, it'd be cool. Like, for instance, if you're looking at ice cover, if you're looking at how the land is changing over time, if you're looking at, let's say, things like how water bodies are changing and evolving and adapting over time, and then if you can start juxtaposing that with human development activities over time and through time, now you can really have a look at this exciting, temporal system dynamics over time. And so that was something that we were talking to some partners in the private sector. And that's another thing I want to talk about partnerships is it wasn't just a question of partnerships amongst government departments and agencies, but something like introducing temporal dimension certainly helps us to talk to some of the geospatial players in the private sector, because certainly they have solutions that you can access today and that you can bring that kind of functionality provided you have the data sets, right? And then also incorporating modeling capability, right? So in this tool right now, what we have is you go in and then you can, plot data points on a map, which is great. But if you want to be able to do what if analysis, you want to do some scenario planning, you want to do some simulations, you want to do some if then else type of analysis, right? So that kind of modeling capability is also something that various users of the solution in the early days had requested. So lots, this tool really is a phenomenal success story of collaboration. but also lots of very interesting future directions where this tool can go. And the very able colleagues in the federal government of Canada and other partners are really taking it in a lot of interesting ways. So this is a part also of a larger government commitment to open science and open data. So if you're interested, you can refer to some of these documents and you can reach out to the contacts involved. And if you want to participate in this kind of line of work and this kind of line of impact, then certainly you're most welcome to do so. So in 2018 timeframe, just around the time, as I mentioned, when Bill C-69 was introduced and was making its way through the legislative process, the Treasury Board Secretariat had also unveiled and released a 2018 to 2020 National Action Plan on open government. And one of the points in that, if you look at point number 5, is about open science. So it was a central facet to that document and that directive. And then also in February of 2020, the Chief Science Advisor of Canada then officially released the roadmap for open science. So although Bill C-69 played an important role in catalyzing this tool and sort of giving it some shape and giving it some direction, but it wasn't the only thing that led to this tool. There's also lots of other aspects to the government of Canada's commitment to open science and open data that resulted in this tool and also fostered and motivated a lot of the collaboration that took place to make this happen. So I am going to stop right here, Ehsan, and thank you so much for giving me the time. And I'm happy to take any questions that come from our attendees. So back to you, Ehsan. Thank you.
Absolutely brilliant.
Thank
so
you.
much, Vic, for the great presentation. I was just excited at many points in the middle of it, and we have a few questions, quite a few questions queued up. I remember Arthur had a question. I don't see him in the backstage presently. So if one can ping Arthur, we can bring him on stage for a question. I kind of have a guess what he's got it super excited on, but let's start with a quick question from the audience. So one is, so Milad in the audience is asking, is it possible to perform a spatial query on a layer and download the results? If yes, what format of data are available?
This is actually a really good question. Thank you, Milad. That's a great question. So one of the things which I didn't show you was that when I clicked on that button that said, show me mappable content, and then I immediately clicked on render this on the map or add to map. Actually, one of the things you can do is when you click on the information part of that record, then you can actually get to see the file that corresponds to the data that is being projected on the map. So your question is specifically, can you go to the map and then do your querying on the map and export the data back out? That, to the best of my understanding, currently is not supported. However, you are able to go from the other side, which is you can click on the actual data set, which represents mappable content, click on the information, go down in that metadata field, and you'll find actually, and it could actually be a composite projection. So you may have a situation where it's not one file, but multiple files that are being fed into that rendering. So you can actually access that content. Sometimes the content may require you to click on a hyperlink and get permission from the original sort of source of that data. But the whole idea, to answer your question, is that spirit of transparency. Thank you. That's a great question.
Okay, wonderful. All right. So let's see. As we're trying to bring Arthur to the backstage so he can come and ask the question. Let's ask another question. So one part that I got super excited about is you talked about counterfactuals. You talked about what if scenarios. Are there does a platform presently support underlying machine learning mechanisms to perform those tasks? Counterfactuals, and if a person has some sort of a causal inference algorithm that would like to, and it is very important for those who are more location intelligence inclined than machine learning. It is very important in cases that we're analyzing significant, climate effects, right, and other, major, disturbances. So, are there, is this underlying mechanism available within the platform? And if not, can folks add to it and improve it?
Yeah, I mean, that's a good question, Ehsan. So, in terms of end user capability, it's not actually available. It was something that came up quite a bit in the early user testing and user feedback, this kind of modeling support, this kind of temporal reasoning support, also the causal reasoning support. So when we say platform, I'd like to say, maybe there's three levels to this. So the Open Science Data Platform is itself called a platform. It runs on the Federal Geospatial Platform that then runs on top of a cloud-based data and cloud engineering platform, right? So those capabilities you're describing, to the best of my understanding, are available three layers down. So in the underlying platform, and you can do your own research, and it's very easy to find out what platform this tool is built on. But those, to the best of my knowledge, are not presently available in the FGP and the OSDP. But certainly, that's a recommendation that when you click on the OSDP website, there's a contact us page. Folks can submit their recommendations. But I do recall that from the early user testing, those were exactly the kinds of things that people were interested in exploring with the tool.
Amazing. And I see that Arthur is here. Arthur,
Yeah.
please move on.
Yeah, hey Vic. Thanks very much for the presentation. That's very clear and very exciting.
Thank you.
Way back when Obama was president, he introduced data.gov in the US, which was an inspired idea, but it stumbles a little bit when you try to use the multiple data sets that are there, because there's now in the case of the platform you're talking about, you've got a common standard, which is a great way to go forward. But when we looked at the idea of bringing additional data sets into an environment, the one we kept crashing into was the differences in intent of the data. So a good example that I use all the time is I want to study butterfly migration related to water bodies. And I just made that up, right? But the problem then is the spatial scale of the data is different, right? So the butterflies the water bodies are polygons, the butterflies, goodness knows, it might be a point cloud, who knows what it is. And then I've got a temporal scale. So the temporal scale doesn't match between the two as well. So we refer to that as the data join problem. You've got two great data sets that you want to use, but you just don't have the commonality to join them together. So adding new data sets, awesome. Automating the formatting of the data sets, awesome. But I'm keen to hear your thoughts on how you solve the data join problem.
Yeah, absolutely, Arthur. That's a great point, and that we also refer to it as the data join problem, and certainly that was one of the issues we dealt with as well. Even in the ideational stages, as I mentioned, that especially the temporal piece of it, that feature was not developed. It was requested quite often, and even at the ideational scale, we ran into exactly that same problem. Now, one way that we had initially thought about could be a possible way to address parts of that problem was to really go to the lowest common denominator, which is to say, okay, maybe this new data set that we're trying to bring in the perfect world would support analysis X, but we can't do it exactly for the data join problem. But can we salvage some part of this data to maybe facilitate some other, maybe lower order type of analysis? But you're right. So, the minute we introduce that temporal dimension, that causes this whole issue. Also, from a data intentionality perspective, what was the data gathered for? I thought that's kind of where you were going with this too, where data were gathered for one purpose, and now they're projected onto this map, and sort of different inferences are being drawn from it that were not the original intent for which how they ought to have been used. So yeah, those were some of the problems that were built, that were encountered during the design of the current version of the platform, Arthur, but also in some of the ideation going on in the next phase of it as well.
Actually, very, very nicely, you touched on the second part of the problem, which is ownership.
Yeah.
So ideally, a platform like this, the perfect solution is you open it up and you allow other organizations to contribute data, right? It's an open science platform, makes a great deal of sense. But there are organizations who say you can have my data, but you're only allowed to use it this way.
Yeah.
And that introduces constraint vectors throughout the data. One way we approached that was by contract. So you published your data subject to a contract, nothing particularly formal, but it just said these are the ways I will permit you to use this data. And when you use the data, you had to say, this is the way that I'm going to use the data, and it matches the contract. But I'm just curious, as this opens up and more data is contributed, have you thought about a solution for that?
Yeah, so I mean, again, kudos to the amazing team that made this whole thing happen. Arthur, you're right. I mean, contracts was the name of the game, because I mean, really, there's one way to look at it is to have this truly open data trust model, and then but still there are contracts involved there, as well as who's putting things in under what reasons, and what do they expect to get out of it. So the incentive models have to align. So I recall that with this tool, given that the early contributors to the data set was mostly government agencies, from a purely risk management perspective and from a purely sort of scoping perspective, everything was articulated within contracts. There were contracts around, there were terms around, let's say, for instance, some of the data sets you see are only available monolingual. Other data sets are available bilingual. Now, being a Government of Canada resource, it has to be, certainly bilingual to comply with the Official Languages Act. So absolutely, Arthur, like there were operational things to consider, and there were legal things to consider, and the way to sort of overcome that was contracts. As you said, when now we start opening this up to private sector players and universities and research institutes and things like that, then certainly the contracts will be looked at again. But even within government departments, there was a lot of contracts that went into set the terms and the conditions of who was going to give what and for what use cases.
Brilliant. Thanks very much, Vic. Let me hand it back to Ehsan.
Yeah.
Thank you. Thank you very much for the great questions, Arthur. So let me ask a couple more questions. This one is simple. Jessica is asking, can we get the link to the tool to share it with the audience?
Yes, absolutely. And if we can put it in the chat, but also if you want to use a search engine of your choice and just say Government of Canada Open Science Data Platform, you'll find it. And then it's got a nice hyperlinks to other pages as well. And I want to quickly go back, Jessica, also to something that Arthur had said, right? Like I kind of forgot to mention that point, which is that what you see here is not an exhaustive list of all the Open Government of Canada data sets, right? So there's a separate website for that, which I'm sure many of the folks are aware of. So you go and do a search and you say Government of Canada Open Data, and there's a whole plethora, like Arthur was saying, of data sets. Now, of the ones there that are relevant for cumulative effects and impact assessments, and the ones that have some connection to mappability or shall we say geospatial aspects to it, those are the ones which are there. So I would highly encourage you that if you are going to look at the Open Science Data Platform, please also look at the open data sets from the Government of Canada. And you may find that there are some that are relevant to you there, which are not in the Open Science Data Platform, that with some sort of degree of precision, you can assign geospatial factors to or features to, and then upload that yourself to do your own analysis. You can enrich your analysis in that way by bringing in data sets which are in the open data repository, but are not necessarily a part of the Open Science data platform. So, but yes, I would just suggest if you want to do a search engine search, or Ehsan, if you can kindly put it in chat, that will be helpful.
Yeah, absolutely. Absolutely. I want to raise one point, though. I think it's very significant to note that location intelligence is kind of everything can be attached to a location, right? Yeah. And such a platform, or availability of which which goes very well together with the open data initiative is crucial. So we can add not only the data that's available publicly perhaps now, but any other private data on the map wherever it makes sense and whenever it's relevant to solve problems that that are just impossible to solve, and one of which I want to refer to the supply chain kind of restrictions that took place due to the pandemic and some other geopolitical factors in the past few months. What do you think? Do you think this tool can be utilized to that effect?
Yeah, that's a very interesting point, Ehsan, and that triggered my memory. And I remember one of our colleagues, or some of our colleagues in the Canadian Centre for Mapping and Earth Observation, used to refer to a tagline they had, which was something like, where it happens, or everything happens somewhere, or something like what you just said, Ehsan, right? Because you're absolutely right. I mean, it's the broader problem sometimes we have, the task we work in machine learning is we have data sets, and in some way, shape, or form, they need to be annotated. So in one level, just like you suggested, Ehsan, one way to think about it is you have some data set where it doesn't explicitly have lat-long coordinates or polygons and things like that, but can we do some other kind of pre-processing upstream to then add those features into that data set and make it. And certainly if you for instance have an IoT sensor somewhere monitoring water quality or monitoring air quality, well, you happen to know where it is, and so right in that data stream, you know exactly the GPS coordinates, right? But do you really need that degree of precision for every problem that you're trying to solve or every analysis you're trying to do when it comes to geospatial data? Maybe in some cases, yes. In some cases, no. And if you're willing to sort of have that ability to be satisfied as opposed to be fully satisfied, then maybe using some of these automated feature extraction and feature embedding type approaches and services could actually help you, Ehsan. So great point, right? And like I was mentioning to Jessica, that you may have data sets in the open data repository which are not currently a part of the open science data platform. Then you may benefit from getting those data out either manually or semi-automatedly or using fully automation. You get it all prepared and then you put it into this tool, and voila, it may help you to do some stuff.
So this is amazing. We have still a few questions left, but we don't have, unfortunately, a lot of time left. So I'm gonna thank our brilliant speaker, Dr. Pant. Thank you very much for accepting our invitation. How fitting it was to start the session today, from the public sector by our chief statistician of Canada, and then end it with your brilliant presence, Dr. Pant. I enjoyed the presentation, and I'm sure the audience has as well. So I have a couple of points to make regarding where to go next and what to do next. So one, and first and foremost, I want to quickly talk about the agenda of next week's event. So as you know, we span over 4 weeks, and it's just 1 day per week the conference runs, so that it's most accessible to everyone. So next week we're gonna have a session, a keynote session from the first Canadian commander of the International Space Station. You can guess, Colonel Chris Hadfield. We also have the CTO of Hyperspec IQ, Charles Mandelo, presenting for us. We also have Microsoft's planetary computer, Matt McFarland, presenting next week. So very excited for that. Also, if you'd be interested to talk to any of our speakers, organizers or other attendees within the conference that you definitely share your passion and interest, you can go to the roundtables for networking. Or if you like themed conversation, there are in the lounge section, there are themed conversations going on, so you can just join those sessions. Lastly, we have, let me see, I think I have one more thing to mention. No, I think that's, oh yes, we have booths. So the booths aren't necessarily accessible. I mean, they are accessible, but they're not necessarily active. Not all of them are active. That's the best way to say it. Some of them are, depending on the presenters' presence today, and some will be activated in the coming weeks. So you can also check out the booths. We have great industrial partners, and some of the presenters also will hang out in the booths. So with that, I'd like to close the session. Thank you very much, everyone. Thank you very much again, Dr. Pant.
Thank you.
We love the presentation.
Thank you so much. Bye for now.